Reactive Extensions for JavaScript and TypeScript. Reactive X was actually developed by Eric Meyer at Microsoft, open sourced in 2012, so it's been around for a while. And it's used by GitHub, by Netflix, SoundCloud, Airbnb, a bunch of other companies use it in a variety of languages because it's not just for JavaScript. Reactive Extensions has Rx.net, there's RxJava, there's a variety of options you can use no matter what language you're using. So we got the, my slides got switched, but we got this observer pattern, iterator pattern, and functional programming. So what does that actually mean if we actually boil that down to its inner meanings? We're trying to go as deep dive as possible. So let's start with the observer pattern. The observer pattern is a software design pattern which object maintains a list of dependents and notifies them automatically if any state changes. So in this example, this lady is the observable, and all these mailboxes are the subscribers, observable. So anytime she has something that changes, she wants to send out a note, something's changed, she just goes through and passes a message to every one of her subscribers. So that's a good representation of observer pattern. Let's go to the iterator pattern next. The iterator pattern provides the way to access elements of an object container sequentially without exposing the underlying representation. So we don't know that these guys are dropping from a linked list. Maybe they're dropping from an array. Maybe they're dropping from some other weird data structure. It doesn't matter. All we know is we want them to come down one at a time. So that's the iterator pattern. And finally, functional programming is a declarative style of building software using pure functions, avoiding shared state, mutable data, and side effects. So you don't have any shared state that's interacting with this. You just have an input and an output. So those are the three patterns that Reactive X is using. Another way you can consider it is Reactive Extensions can be considered simplified asynchronous functional data streams. And if you want to even boil this down a little bit further, it can be considered observable objects that can be subscribed to by other methods, and then return an asynchronous stream of updates, which can be modified through functions. So that kind of sounds a lot like promises. And so trying to find the difference between RxJs and promises, kind of what's going on there. So full disclosure, I did a lot of Googling when I was creating this presentation. I'm like, what are the differences between RxJs and promises? I kind of got a little bit too into RxJS in the sense that it seems like every time I Google anything, it can relate back to RxJS. No matter what it is, no matter what the quote, RxJS, just Google everything just seems to come back RxJS. So I found a quote that sums up RxJS, the difference between RxJS and promises pretty nicely. RxJS is a promise that can last forever. See, it just Google it and it's just there. So there are basically four main ways that RxJS or observables are different than promises. The first way that an observable is different than a promise is an observable handles a stream of async events instead of a single event. So whereas a promise has a single event that gets passed through the chain, an observable will send a stream of updates. So in this example here, we have this observable, and it sends three values, one at 1 second, 2 seconds, and 3 seconds, and it completes. And so when you subscribe to this, 1 second in you get 1, and then it's not done, it fires off 2 a second later, and 3 a second later. So that's the big difference between RxJS promises, is just a stream of events. The second difference, and this is one that can kind of catch you if you're used to promises and then you start using observables, and it's a little bit of a catch, is an observable is lazy. So if you're setting up a promise, the promise is going to fire off immediately when you create it, and it's going to run whether or not you attach a then to it, whereas an observable does not fire off until you subscribe. So here we set up an observable, 1 second, 2 seconds, and then we wait before we actually subscribe to it, and you can see this console log 3 is hitting first before the actual observable fires off, and then the observable fires 1 and 2. So it doesn't actually do anything until it's actually subscribed. So it's not running in the background or anything. It's just waiting until your subscription's in there. I found that screenwriter Charlie Kaufman had some trouble with the concept of lazy loading. When I was Googling around, he said, I don't subscribe to anything. I sit there and try to think about what seems honest to me. And the challenge is Charlie Kaufman's observables aren't going to execute, which is why he's probably still just sitting in the because nothing's happening. He's not subscribing. So the third main difference between Rx observables and promises is that an observable is cancelable. At any time, any point in time, you can kill the observable and it will garbage collect, clean up everything. And some of the main ways that you can kill observables are using these take until, take while first. Some of those things, what will happen is, in this example here, we have our initial observable, 1, 2, 3, and we set up a new observable. And this one's going to fire off at 2.5 seconds. And so in our subscribe, we're going to be using something called pipe, and pipe's a way that RxJS uses to modify observable subscription. And so what we're going to do is we're going to pipe take until, and we're going to take until B fires off. So when we actually run this, we're going to get 1 firing off after 1 second. We're going to get 2 firing off after 2 seconds. And this guy's going to say, hold up, I'm sliding in here, and he's going to say, kill everything, go away. And it's just going to stop, nothing else is going to fire. So at any point in time, you can have an observable that actually returns forever, but if you pass in a take until, you can cut it off whenever you need to. This is really helpful. Make sure you do this for garbage collecting. We'll get into that a little bit later. And then finally, the fourth benefit of observables over promises is observables can be retried. So this is, I think, one of the main reasons why Angular itself switched from promises to observables for their HTTP client is because if you're on a spotty connection, you're doing an API call. If it fails, you don't have to necessarily worry about retrying that somewhere else. You can just go and pass in a retry and keep retrying it as many times as you want to make sure that the response goes through. And so to demonstrate this, we have an observable that fires off once, and then it throws an error before it completes. And then we're going to retry that 3 times. So we fire off once, and we hit an error. Then we go and it says, okay, we'll try it again. Fire off again, hit an error. It's going to retry it 3 times, and then eventually after the 3rd time, since we gave it a limit, it's going to say, okay, this thing's not going through, and it's going to throw off the error. So all that said, observables and promises are still compatible. So when they designed RxJS, they wanted to make promises first-class citizen in the framework. So any operators that accept observables can also accept promises. So if you're doing those take until that we showed earlier, you can pass a promise in there and use that as the kill switch. So you don't necessarily need to switch everything to use observables all at once. If you have a large site and you want to experiment with RxJS in a small section, you can use promises if you already have built in and pass those in as first-class citizens RxJS. Another thing you can do is if you have a promise you want to treat it like an observable, you can use observable.defer, pass in the promise, and it will wait to execute the promise because promises don't lazy load. So it's going to wait and execute that lambda until after the subscription happens. And so it'll treat that promise just like an observable. So the next thing I'd like to talk about is some of the derived types from observables. So when I talk about observables in RxJS, it's kind of the basic type overall for RxJS. There are a bunch of derived types. The most notable, the main one is called subject. And the author, Ingrid Bengus, did a great job summarizing the differences between subjects and observables. It's amazing just how many just random people from all walks of life, like RxJS, and they're passionate about it. So she said, no matter what the subject is always the same subscription. So before we get into subjects, let's just go into observables a little bit deeper. So observables only execute when you subscribe. We talked about that a little bit earlier. And they will also re-execute every time you call subscribe. So if you have an observable, you call subscribe twice on it, it's going to fire off that Lambda, including any side effects for each one of the subscriptions. So this can be a little bit challenging if you're like, why is this thing going on 100 times? It's because you're subscribing 100 times. So how do we combat that? The big way that we can get around that is using subjects. So subjects are observables that are also observers, and they'll send up their updates to all the subscriptions for the subject. And they also, instead of having next inside a Lambda function, so this observer.next is passed to the Lambda, next is actually on subject, is right on the subject itself. So you can update a subject externally without having to encapsulate it into a Lambda function. And so here we have a similar thing going on. We have A as a subject, and then we're going to, tap is just a way to modify the observable to do a side effect. So we're going to have a side effect fire off there. And then we're going to subscribe twice to the subject. And then we're going to fire off next. And so when we fire up next, so here's the console log 1, it's the first thing that fires. And then when next fires off, it executes the subject and it hits the side effect. You get the first result, then the second result. And so these don't fire off the side effects separately. It's all sent through the same grouping. And so subjects in and of themselves have a few different internal derivatives. The most common, the one I really like and I use the most day to day is behavior subject. So behavior subject is a lot like a Knockout.js observable. If you guys have used Knockout.js in the past. It's a subject that will store the latest value. So when you first set up a behavior subject, you pass it in an initial value. And then every time somebody subscribes to that, it will pass the current value immediately without waiting for an event to fire off. So you can use this as a store of value, and it's really useful for kind of having that shared state through multiple components. Replay subject is similar to behavior subject in that it sends out the last value, but it sends out the last X number of values. So if you had, for instance, like a chat client where you wanted to populate like the last 10 messages when you first open it up and have a new subscriber connect into the chat, you could use a replay subject and grab the last 10 messages and pass those through immediately when they first subscribe. Async subject's a little bit different in that it's a subject that waits until the whole subject has been completed, until the complete's been fired, and then it will send the final value to subscribers. This is kind of interesting, like why would you ever want this when you have some of these other options? So the main reason for async subject, it's great for caching one-shot resources. So, and the reason is because it will also send the value to latecomers. So most of the other items won't fire off subscriptions if they're already completed. So once the subject gets completed, so if you have an API call and you call, for example, Angular, the HTTP client, you get a response back, you complete, you can send it to the current people, but new people won't get that response unless they're using something like this. So an async subject will cache that response. So anybody afterwards who calls that same subject will get the response even after it's completed. I also want to go through one little weird derivative of observable. I put it on the subject list because behind the scenes, the connectable observable is actually a subject. But connectable observables let you treat observables like subjects by providing a connect function that will kick off the observable. And then they will share the subscription across all the clients. And the main way to use connectable observables is with the multicast operator. So the multicast operator is basically, if you have an observable, you don't want it to fire off for every single subscription. You want it to fire off once and have everybody use the same thing. You can use a multicast. So here we have an observable with side effect. We have, and we're going to pipe it through multicast into a new subject. And then when we subscribe twice, you see the side effect is executed once, and then the two responses happen. And the real key here is that because it's piping through a connected observable, it has a connect function that initially will fire off this initial lambda. If you're reading any guides about RxJS online, or a lot of them are going to use publish and share. And instead of getting, if you're confused, I was really confused about what the difference was between multicast, publish, and share. So publish and share are basically just implementations of multicast that do a couple defaults. So publish will just multicast to new subjects. So you can just take this line right here and replace the whole thing with publish, and it'd just be a shorter way of saying the same thing. Share, on the other hand, will multicast to a new subject, but it also has the additional benefit that after the subject's complete, it will refire off this initial observable if any new subscribers jump in after it's completed the first time. So they'll get responses too. So there's a little bit of a difference there, but basically, if you're confused about the differences, multicast is the base class, and publish and share are just derivatives on top of that. So there's not a whole lot weirdness there. So next I'd like to talk about RxJS operators. Especially, I'm going to focus, because there's a lot of operators, on operators to combine different observables, because I think those are the most interesting ones. Because we've all worked with maps and filters and stuff like that in a variety of different languages, so we kind of know what those things do. This is kind of where RxJS really shines above other observable libraries like Knockout.js or even some Promise stuff. You can combine, out of the box, RxJS lets you combine observables in 3 main categories. The first one's combine a bunch of observables into an array in a variety of different ways. You can combine them into a single stream, so the same stream has a bunch of them. Or finally, you can transform one's observable to a different one. So here's a real challenge with RxJS, and this is one that I think hits everybody, is there are a lot of built-in things that RxJS has, and it's really confusing to know what in the world you should do for each one of these things. So this is a challenge that I've had. I actually had a project where for several months I was using the wrong combine operator, and I didn't really notice because it didn't come up until months in. It had this weird issue, and I was like, what is going on here? And I finally realized because I'm using zip instead of combine latest. And so sometimes it's a little challenge to like, which one is it you actually use? And the solution to this, my favorite way to figure this out is using marble diagrams. And there's a really cool site called RxViz that lets you build your own marble diagrams. And so you can kind of just build the works and then run it, see what happens. And that's a really powerful way to see what the difference is if you're trying to compare and contrast different observables. So here let's get started with an array first. If you want to join observables in an array, you go look at the documentation. You see there's 4 different methods for combining observables into an array. What's the difference? You know, you can read through it. It's kind of confusing, but if you really want to go into what's the difference here, you should. You just need to go into the marble diagram. So this is RxViz, and here I set up 2 observables, and they're firing off. One's firing off every second. The other one's kind of random. And if we scroll down a little bit, because this screen is, can you guys see this in the back? All right. Scroll down a little bit. I'm actually going to put some space at the bottom because make sure it goes up enough. So what I'm going to do here is RxViz lets you not only see a marble diagram for a single observable, it'll let you see multiple marble diagrams going off at once. If you return it as an observable of observables, this is just a fancy way for this tool to accept it, so it doesn't really matter too much. But basically what I'm going to do is I'm going to create a new observable at the end, and I'm just going to pass each one of these observables into as an event that's getting fired off by this outer observable. And then in here, I'm going to run combine latest, I'm going to run zip, I'm going to run fork join, and with latest from. And then I'm using start with just to give a little tag so I know which one's which. So let's see what happens here. So we go fire this off. You see observable A fires off every second, observable B fires off, and so on. And so combine latest will basically take the latest state from each one of these, and anytime there's a state change by either one, it's going to drop it into the combined latest array. So you can see here, A and A gets dropped, A and B gets dropped in here. It's going to keep going every single time there's an update. It just grabs the latest one and passes it through. So zip, this is the one I was confused with. Zip will always take the first in the first or the second in the second. So zip fires off A and A first, and then it doesn't do anything for these guys because it waits till it gets 2 from each of them, and then fires off B and B, C and C, D and D, and so forth. Fork join, which you can't really see because share, it waits to the very end, and then it will just fire off the last value once they're completed. So this is good if you're having a bunch of things, you want to wait for them all to do something, and then once they're done, you just want to see what the result is. Use fork join. And then with latest from, we'll always take fire off with the initial observable, and it's a piped operator, but it'll also include the current value of a secondary observable. So it's just going to fire off the same, but it's going to include a current value of observable B at the same time. So it kind of gives you a really easy way if you're like trying to figure out, you can mess around with this, you could change the timings and just kind of use a tool like RxViz to figure out what exactly you want to use for your specific situation. And so if we go here, like I said, most of the time if you're going to be joining stuff into your array, you probably want to use combine latest, the little gold star there, because that's the common one. But there are circumstances where you want to use the other ones. Like if you always know that you have an equal number of items coming back, and they're coming back at random times, you can use zip to make sure that you pass them through one-to-one. So I have another quote. While I was Googling and doing my extensive research, I found out that actress Beverly Mitchell could really use some help dealing with combining stuff. So she said that it's a tough client if you're trying to combine her acting career or college career, and she needs to learn about combine latest because it makes it really easy to just join this two. You always get the latest values from both. So again, just to jump into the same sort of topic, joining observables into a single stream, there's a variety of different operators that RxJs provides. Merge, concat, race, start with. Start with's a little easier to figure out, but still you might be like, what's going on here? How do we figure this out? We can go back up and check out RxViz. And again, I have my 2 observables, and I'm going to put some spaces back here so you guys can see it again. I'm returning a merge, a race, and a concat. Let's see what's going on here. So here we have our initial observables firing off. And this is kind of a tiny screen, so these aren't as clear as they used to be. So I'm just going to zoom out just a hair. So if we look here, we have our initial observables going through. And so merge actually just drops whatever the latest value is from either one of the internal streams into a single stream. So you have lowercase a, capital A, and they're all passed through on a single stream. Whereas race, on the other hand, what it's doing is it's finding whatever stream returns a value first, and then it just unsubscribes from everything else and goes with whatever returns first. And then finally, concat will run the observables in sequence. So it's going to run through everything from observable A And then when that's finished, it's going to run through everything from observable B. So it's a quick way to figure out differences between the different observable types. And let's start with, we've been using a lot just to demonstrate, put that little initial value. It just passes through an initial values, and so we can use that to kind of tag our different streams. And again, merge is probably the most common use case because it just combines both in the same stream. Finally, I just want to go through mapping observables. And mapping observables are really powerful. This is one of the main features, I think, of RxJS. And behind the scenes, these operators are very simple what they're doing. Basically, they just take an observable that they're watching, they'll subscribe to it, and then they create a new observable every time an event happens, and they pass that event's result into that new observable, and so you can do stuff with that. So the main maps are merge map, switch map, concat map, and exhaust map. So just to talk through these real quick before we go to the visualization, merge map is a very naive implementation in that it will always subscribe to, so if we have a new event coming from our initial observable, merge map is going to create a new observable for every single event that comes from the initial one. And it won't unsubscribe from anything. So you're going to get it's called, I call it the messy map because it just dumps everything through there. And in the end, you get a lot of subscriptions going off at once. Switch map is one that whenever it receives a new event, it will unsubscribe from the old event and then create a new observable, and then unsubscribe from that when the new event happens. Concat map is good for if you need to queue up stuff. So concat map will queue up a new observable every time an event happens, and it will wait until that inner observable finishes before it fires off again. The number 2, so it'll fire off all the inner observable for the first result, then all the inner observable for the second result, and so on and so forth. And then exhaust map is the opposite of switch map in that it ignores everything coming in from the initial observable until the inner observable completes. So we can go look at this too. So let me zoom back in so you guys can see this. So we have our observables. And then down here, we doing a switch map, concat map, merge map, and exhaust map, putting a starting on it. And I'm going to zoom back out. And so here, switch map is the first one on this list. And so A fires off, and it's going to start observable B. And so observable B is going to fire until we get a new result from A, and then it's going to kill that one and start a new one. And so every time it's going to kill that and start a new one. And then compare that with merge map, which you can see it actually has, it says ×2 because it's having multiple things happen at once here, where it's just running all of the inner subscriptions concurrently. And then combine map here, we'll do an A, B, C, D, E. It'll finish the inner observable, and then it'll run the next generation of the inner observable. And this one will actually keep going farther. For every single one of these that happens, it's going to queue up those guys. And then exhaust map here runs through A, B, C, D, E, and then it waits to listen until it hits another event from the outer observable and goes forward. So again, this is just a great tool. You can test around with a bunch of different operators. If you have any questions about RxJS, I would highly recommend jumping into that. But enough about those things. So again, switch map's the most common one you probably want to use. If, let's say, I got a quote from Tacitus, who was a fan of custom operators, it looks like, from what I can tell. He said a custom, I'm sure an operator, adapts itself to expediency. So one nice thing about RxJS is you don't have to just use what they provide. You can build your own operators, and it's really simple because it's very functional and it's straightforward. So you don't have to do anything weird, override any methods or anything like that. You can just create a function and have your own operators happen. RxJs has many operators that are also already defined, but if you need something special, you create your own, or if you want to combine a bunch of operators into something you're doing commonly, so it's a little bit cleaner, you can do that too. Just as a note, like the observable itself, pipe operators only run when it's subscribed. So this isn't something that's going to be running in the background, it's going to be something that happens on subscribe. So let's go through how you create your own custom operators. So basically the formula is you want a wrapper that accepts a function, or that returns a function, which will accept a source observable and return a new observable. So a wrapper that returns a function that accepts a source observable and returns a new observable. So with my little simple example here, I have a split string. So I give it a split on, which defaults to a comma. And so here I'm going to return a function that accepts a source observable, and it's going to return a new observable. And inside this new observable, I'm going to subscribe to the source, and then on next, I'm going to do my little split. So when I get a value from the source, I'm going to fire off next to my new observable, and then error included, I'm just going to pass right through. So that don't really care about those guys for this. So it's pretty simple and straightforward. Just remember, wrapper accepts a function. A wrapper that returns a function that accepts a source observable, returns a new observable. If that's too much, you can also just use the existing Rx operators and just wrap those. So here, the second thing does the same thing. I create a split string, which just returns math for a split string. So and that does the same thing as this big one at the top. So I've actually used the custom pipe operators in the real world, and this is one that I have used very often. So I have a project that has a lot of data objects that have dependencies. So if I get a person, I need to go call another API and pull it back in the person's details and so on and so forth. And you can do that with switch map. That's kind of the common way to set that up. But eventually it can get a little bit hairy if you have a lot of stuff going at once, especially if you don't want to just switch. You want to return the initial user and the details all together. You need to do something with everything at once. So this operator I wrote, then combine latest, is basically, it's an operator you put to a pipe that combines whatever the internal observable you pass with the outside observable and passes both of them through as an array. So if you can see down here in my little example here, I have a get users David, which will return an observable. It's going to pipe it to then combine latest, and I'm going to get the user, and I'm going to get the number of kids I have. So return that, and then I'm going to do then combine latest. You see here on the second one, it's going to have both the user and the kids in an array. And then I'm going to get my humor style, passing in the length of how many kids I have. And then I'm going to subscribe to all of that. And in the end, it's obviously dad jokes. But and I have a example for this. Let's go back up. Get away my secrets. So zoom back in. So here I'm using then combine latest, and this example is not as flashy, but basically I have an interval that fires off every 1,000 every second, and then every third of a second I have a then combine latest that fires off in there. So it's doing the same thing as combine latest, but it's just passing through this x value, so I can use that to set up. So the first interval, 1 second, fires off, and then it waits for the inner interval to also fire off before it returns both of them. So it's something I've really used, so feel free to steal that and use that in your own projects. It's something that's been really helpful for me. So next section, so how to use RxJS within our frameworks. I did have a quote here it was so cringeworthy, I had to remove it. Like, that tells you, if you've seen the quality of the quotes I've had before, it tells you how bad that was. So since RxJS, it's kind of independent. You can use it regardless of the framework you're using, but there's a couple of ways that might be useful depending on what you're using. So Angular actually has the best support for RxJS out of the box. And one of the ways that you can use RxJS in Angular is using the async pipe. So here we pass in an observable and pipe by async, and then you define what you want that observable to go to. And then you can use that inner one to name the description and use it inside your view. If you do this, Angular is actually going to handle all of your subscriptions, your unsubscribes, everything on itself, and so you don't have to really worry about it. So it's kind of nice that Angular gives you that support. If you use React and you're using something like Redux, you can use RxJS as a poor man's store and actions. So you can use it without using Redux by using behavior subject to store your data object, and then you can just call next on that and update it without having to bring in any Flux library. And this is I put a link in here that's an example of somebody who's been doing that in one of their projects. And then Vue also supports RxJS. There's actually a built-in package called VueRx that lets you use RxJS to send updates and wire up subscriptions. So the next piece of this presentation, there are some challenges working with RxJS. If you've done it at all, you've probably come across some of these things. So I just want to go briefly into some of the challenges I've seen with RxJS. Interestingly enough, Walt Disney, I found out, had a lot of trouble. He was getting repeated API calls that returned 200 OK responses. And he was trying to figure out where all these repeats come from. So he said he doesn't like to repeat success. He likes to go on and do other things. You know. So how do you prevent repeats? Yeah. So there's a couple of ways. I've noticed this is something that happens pretty commonly if you're maybe not paying attention and try to look at what's going on. But one of the main things is making sure if you have multiple subscriptions or multiple subscribes that are happening, use a multicast operator so you make sure that those only fire through once, if that's unintended. And even better yet, if you can combine them to a single subscription and use pipes to kind of combine everything so you only subscribe once to your component, that's another way that's really helpful to prevent a lot of stuff going off where you're not expecting. And then finally, just make sure you filter out irrelevant values. So if you have some responses come back that you ignore, just make sure you filter through those before you subscribe so you don't have to deal with those inside your subscription itself. And I also found out William S. Burroughs had a different problem when he was working with RxJS. He just couldn't figure out garbage collection in his web app. It just kept using more and more memory. Said that he has an old feeling in his leaking heart. I'm pretty sure that the old feeling is an uncompleted observable. So how do you prevent memory leaks in RxJS? So one thing to keep in mind is observables and subjects are only cleaned up when they're completed by default. So they're not going to clean themselves up when you destroy your component. If your subject isn't completed, it's not going to be released, and so you're going to get memory leaks from that. So make sure that you always unsubscribe from any subjects or observables that are open. So anything that you know isn't going to be completed. Unsubscribe and teardown methods like ng-on-destroy or component will amount. And if you want to go a step further, you can create a base class for your components that have some helper methods. I know in our project we have a base helper method that you pass it in all the subscriptions. You want to make sure it's garbage collected. And then on destroy, the base class will just go through that list that it saves and just unsubscribe from all of them. Or finally, another way you can do that is take until, and use take until to complete the open observables by firing off a event when ending your teardown method. And for all this stuff, we're going to do a little demo. This is a little bit more full featured than our other demos. So if I go here, this is just an Angular app. It's pretty basic. I have a service. Let's see if this lets me go through here. So this service is just a wrapper around the subject. So I have a subject. I want to share it across a bunch of components. And all the subject's going to do is every 2 seconds, it's going to change the word it uses. So let's go to this boat component. So this boat component is kind of the naive way to use RxJS with Angular. So we go here, we have our boat component, make a little rhyme. Make sure we have a rhyming word in there. And here we have a string that we're putting on our component. And then we, in the ng on init, so we pass it, we instantiate the float service. We just go grab the float d, and you can ignore this line for now. This is just a way to keep up the count. So what I'm using this for is I'm putting a count on the window to make sure it doesn't get destroyed when you change back and forth through the pages. So you can kind of make sure that that count stays accurate as you go back and forth. Then we're just going to, when we subscribe, we're going to set this float to X. So every time we get an update, we're just going to set it to X, right? So here we go. We have our thing. We're on a boat. We're trying to float. And we're going to go around the site, yada, 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 back and forth. And you can see here, this is not incrementing by 1 every 2 seconds anymore. It's incrementing by 3 because we've gone back and forth. And so as we keep using the site more and more, these old subscriptions are going to keep piling up and becoming more and more memory leaks inside the application. So what do? In our code component, we have another option. We're going to do the exact same thing. We have the float as a string, but the one difference we have is we're going to use take until. So take until, we have set up a new subject called complete, and the only thing this does is it fires off on destroy, and then it completes itself. And then everything else is the same except this take until method, is called with complete. So here if we go, look at the output. So we go back and forth. And so you can see here, the code component is still incrementing by 1 because the take until is destroying the subscription every time before it changes pages. So you make sure you don't have those hanging subscriptions. And then finally, just showcase Angular's built-in service here. This one, we're not actually going to, go component. We're not actually going to subscribe at all inside a component. We're just going to pass the float as a subject and then use that with the async pipe. So we get the float subject, async pipe, define a variable, spit it out. And so we're going to have Angular handle the whole thing. And we're not doing anything except the tap to record the account. So if we go to Go component, you can go back and forth. And again, it's just going up by 1. So it destroys itself, everything works. And that's that demo. So anybody have any questions?
Yes.
Go ahead. Give me my gifts. Giphy for the most part, but it's been a variety of places.
Any struggles with older browsers and RxJS and polyfills and such in your experience?
I haven't worked with anything too old, but I haven't seen any problems so far.
I have, so that's why I'm interested in hearing about that.
I haven't typically worked with anything more than a couple versions out.
So IE11 in terms, you've not seen any problems with it?
I haven't used IE11 since. Any other questions?
I guess the nice thing for me, coming from the knockout world, is that it seems to wrap a lot of the difficult parts that you had to get just right to not have duplicate subscriptions running. It seems like all those functions that you can do just take care of all that.
Yeah,
I really want to watch this.
Yeah,
and it lets you narrow that down.
It does make it pretty easy to go through stuff. that. Like I said, I haven't used IE11, but I haven't had to support that. But as far as with the browsers I have been using stuff, it's been really helpful for some of that, getting those strings of events.
Does the unsubscribe do the garbage collection?
Yeah, so unsubscribe will also garbage collect if it's not completed. So if you have a subscription, the subscription will turn a subscription object that has an unsubscribe function on it, and you can call that from wherever to also make sure that you unsubscribe when you need to.
I've got a large app using this. We're doing that, and I'm still seeing memory consumption. You know, collection's not happening as fast as the unsubscribe is firing. So I was curious if there was any.
So I know in JavaScript itself, sometimes their garbage collection can be a little weird, where it will wait a while and you'll see memory shoot up, and then it will garbage collect all at once. I don't know if there's an easy way to solve that with tools, because I think that's a limitation of the JavaScript engine a lot of times. But if the subscription is completed and or it's unsubscribed, it should be available for garbage collection whenever that happens, at least.
Well, so this is kind of more like an Angular version. I've seen on some reactive libraries where you can kind of subscribe to UI events and have those become observables, and you can essentially then transform those into network calls. And does Angular have support for that?
Yeah, so RxJS out of the box has support where you can pass in native events and transform those into a subscription as well. So I didn't really get into that in this presentation, but it does have support if you want to use, on key down or any of the native events, you can pass those through as a subscription as well.
In fact, that's why deep balance is used a lot.
Yes.
When users are inputting text into a text box, you can use deep balance and wait to not fire off your API call after each click event, but wait a certain amount of time and then deep balance the whole time.
Yeah, because you could do something. I think we did something like that on a mobile app using where as you were typing, it would be getting you search results, but it would have a little bit of a delay so that you're not immediately firing off like. So yeah, exactly. You're not firing immediately.
Any other questions?
Could you touch on hot and cold observables actually?
Yeah. Basically, there's different. So a lot of blogs online use the terms hot and cold to describe observables. So a cold observable is like a traditional observable where it is not running. It's only going to run once you subscribe to it. Where a hot observable, so the connectable observable subjects are considered hot observables because they will they're running already, and they'll send the updates to anybody that subscribes to them. So that's kind of I didn't really get into that in this presentation, but that's another differentiator that if you're reading about this online, you're going to see a lot of talk about. So I did want to, if you have more questions, come see me afterwards, and I'm happy to talk to you about RxJS. I have a couple of resources I included in the slides. The first one's RxViz. It's really helpful for seeing how those different operators interact with each other if you want to build out something. The second one's RxMarbles. So RxMarbles also shows marble diagrams. It has a marble diagram for pretty much most of the operators already built in, so you can go look up and you see a kind of a quick marble diagram that's already built out. And then finally, if you really are interested in RxJS, read Ben Leish's blog about RxJS. He's a software engineer at Google. He's a really smart guy. He does a lot of interesting things with RxJS. So he's given me tons of help through the blog over the time I've been using RxJS. There's just a lot of really good content there. So if you want to copy the presentation, the QR code, or I think Katie is probably going to email it out to everybody later on. And I hope you guys enjoyed it. And if you guys have any questions, come see me. Thanks.